In this lecture, we will learn about section modulus. Section modulus is the ratio between the moment of inertia about the neutral axis to the distance of the outermost layer of the neutral axis. So y max, and that is represented by a letter called Z. So section modulus is denoted by the symbol Z, and that is the ratio of the moment of inertia of a section about the neutral axis to the distance of outermost layer from the neutral axis. So I by y max will be the Z. So we will find Z only when y is maximum. Now we know m by I is equal to sigma by y. Now from this equation we have known that we will get this sigma stress maximum only when y is maximum. So we can write this equation as this: m by I is equal to sigma max by y max. So when y is max, then sigma is also max. So from here, if we rewrite the equation, and it will be look like m is equal to I into sigma max divided by y max. So it will look as this: I by y max. I by y max is basically Z. So we will learn m is equal to sigma max into Z, and this formula is very needed for problem solving. Now we will start with a problem. Say, for example, we have a simply supported beam which is having uniformly distributed load. Okay, simply supported in both ends, having length L and carrying W per meter, W load per meter. Okay, now let us work with its problem statement. Statement is a rectangular beam. Rectangular beam means its cross section like this, 200 mm deep and 300 mm wide. So this is 200 and this is 300. Okay, is simply supported over a span of 8 meters. So L is equal to 8 meter. It is told what uniform distributed load per meter the beam may carry if the bending stress should not exceed 120 Newton per meter square. Bending stress should not exceed 120 Newton per meter square. That means sigma max is 120 Newton per millimeter square. That is given. So depth is given, which is 200 mm. Width is given 300 mm. L is equal to 8 meter. That is given. And what we have to find out? This value of W. Okay. So first of all, we need to find out Z, where Z square equal to I by y max. Now for I, for rectangular section, we know BD cube by 12, and y max is d by 2 bd cube by 12 and d by 2. So this becomes d square by 6. So putting those values, 300 into 200 square by 6, we will get 2 then 6 number of zeros millimeter cube. Okay, this is J. Now we will use the formula M is equal to, we know in our shear force bending moment chapter we have known that bending moment for a simply supported beam is WL square by 8 in this case. So here L is equal to 8, so 8 square by 8, of course it will be W into 8 Newton meter. So W into 8000 Newton mm, as this is in mm cube, that's why we are converting this into Newton mm. You have to be very careful about its units when you are solving the problems. Now you have the formula again, M is equal to sigma max into Z. Okay, so from here we will put 8000 into W is equal to sigma max was 120 was given Newton per mm square. So into, and the value of Z we have already found out, meter cube. So W is equal to 30 into 1000 Newton per meter or 30 kilonewton per meter. So first, from the shear force bending moment chapter we have learned the bending moment, and then we will equate it with the formula we have found out now, sigma max into J. So this is how we need to solve the problems. Let us solve the problem for a little difficult one. Okay, we have a beam having cross section like this. Okay, this is 11.5, this is also 11.5, all in mm of course, and from here to here it is 225 mm. Okay, this is its neutral axis, this is 100 mm, and this is 7.5 mm. This is the beam we have. The question statement is, the beam is simply supported over span of 12 meters. So it is simply supported over span of 12 meter. Simply supported over span of 12 meter. And the maximum possible bending moment, that means sigma max, is given 80 Newton per mm square. What concentrated load can be carried at a distance of 4 meter from one support? So if there is a beam and it's carrying a concentrated load at W, so this is A, this is B, this is C, where this C to B is 4 meter and the total length is 12 meter. So now how to find out the reactions RA and RB? Yes, by taking moment about A and equate them, the clockwise and anti-clockwise moments, we will get RB. And when we take moment about RB and equate them with 0, then we will get RA. So if we take moment about A, we will get RB into 12 is equal to W into 8. So RB becomes 8 into W by 12, or 2 by 3 into W. So RA will be, of course, W minus 2 by 3 will be W by 3. Okay, this is the RA and RB. So this is W by 3, this is 2W by 3. Okay, now of course the bending moment at C will be maximum. That is very clear to us from the previous chapter's concept. Okay, so the maximum bending moment M max can be found out by 4 distance into the force, 2W by 3 will be equal to 8W by 3 Newton meter. So 8000 W by 3 Newton millimeter. This is Newton meter, this is Newton meter. Okay, as because the 4 was in meter. Okay, now the moment of inertia of the beam is BD cube by 12 for the total cross section is 100 into 225 cube by 12 minus, we will subtract this portion. So how can we subtract? The thickness is 100 minus 7.5. This is the width into depth is 225 minus 11.5 into 2 BD cube by 12. So if we find out the answer, we will get 313,866,47.45 mm to the power 4. Now using the relation M by I is equal to sigma by Y, max, this is also max, it occur. So we will find from here, we will find Y max, and Y max will be equal to sigma max into I by M, and we will get the value 112.5 mm. That will be Y max. Now again we will go back to the previous formula. M by I is equal to sigma by Y. When all these quantities are known, we put the values 8000 into W by 3. What is this? This is M. Where I have found out? Here. So 8000 into W by 3 divided by, we have just found out here I value 31386647.45. Okay, will be equal to, this is given max value at 80 and Y max is 112.5. Okay, now upon solving this, we will get the value of W, and that will be equal to sorry, this is point load, this is point load. So W is equal to 8369.77 Newton. So this is how we will solve the problems. These are the main formulas. M by I equal to sigma by Y equal to E by R, and M is equal to sigma into Z, and Z equal to I by Y max. So our major formulas are this: M by I, sigma by Y is equal to E by R, and Z is equal to I by Y max, and M equal to sigma max into Z. So this is the major formulas. These are the major formulas required for this chapter. Nothing else. Only these three formulas. And how to find out M. How to find out bending moment at any section. That concept will be required here, which you have already acquired in the previous chapter. So on the next class, we will study about the bending stresses in unsymmetrical sections. Okay, that will gonna be really interesting. So stop today.